This is lesson 9.1, powers and exponents. A number that is expressed using an exponent is called a power. The base is the number that is multiplied. The exponent tells how many times the base is being used as a factor. So for example, 4 to the third has a base of 4 and an exponent of 3. And 4 to the third is 4 times 4 times 4. That's multiplied 3 times, which is equal to 64. Any number except 0 raised to the 0 power is defined as 1. No matter what the number is, if it's raised to the 0 power, it is always going to be 1, as long as it's not 0. So 1 to the 0 is 1, 2 to the 0, 1, 3 to the 0, 4 to the 0, 5 to the 0. Any number to the 0 power, as long as it's not 0, is equal to 1. So example 1, write each expression using exponents. So for the first one, we have 6 used as a factor 4 times, so this is 6 to the 4th. For b, we have negative 2 multiplied 3 times, this is negative 2 to the 3rd. And make sure you have parentheses around the negative 2. If you write that without the parentheses, it is not the same thing. For c, we have 1/2 multiplied twice, so that's 1/2 squared. For d, x is multiplied 1, 2, 3, 4, 5 times, so that's x to the 5th. Now for e, this looks a little different, but you see we have the same factor twice, c minus d and c minus d. So this is c minus d squared. And for f, we have a 9, and then we have an f multiplied 4 times, and then a g. So this is 9, f to the 4th, g. Okay, there's a few for you to try yourself, so go ahead and pause the video and answer these 4 questions, and then when you're ready to check your answers, hit play. Alright, this is 9 to the 4th, negative 1 squared, w to the 6th, and 1/2 x to the 4th, y to the 3rd. Reminder, in order of operations, the E in PEMDAS stands for exponents. So exponents should be evaluated after parentheses, after the P, but before multiplication and division. So we always do the exponents before the multiplication or division. So example 2 says evaluate each expression if A equals 5, B equals negative 2, and C equals 3/4. So for the first one, 10 plus b squared, we'll replace the b with negative 2. So this is 10 plus negative 2 squared. Again, make sure you have the parentheses around this, otherwise this is not the same thing. And then when you go to put this in the calculator, again, if you do not use parentheses with the squared on the outside, it will not give you the right answer. If you type in this instead, without the parentheses, it will do order of operations. It will square the 2, and then it will make it negative. That's not what you want. You want negative 2 squared. So you have to use parentheses so that the calculator knows that the negative is part of the number that's being squared. So if you put that in correctly, this should tell you that negative 2 squared is positive 4. And then 10 plus 4, of course, is 14. Okay. For b, we want a plus b to the 3rd. So we'll replace the a with 5. And we'll replace the b with negative 2. And of course we want to take care of the parentheses first. So 5 plus negative 2 is 3. And now we'll evaluate that exponent. 3 to the 3rd is 3 times 3 times 3. So that is 27. And the last one, 2 minus c squared. C is 3/4, this is 2 minus 3/4 squared. Now in this case, this minus stays outside the parentheses because it's not part of the C. This is 2 minus whatever C is squared. So we want this squared first before it's subtracted, so the minus stays on the outside. Alright, and if we square 3/4, remember that's 3/4 times 3/4, we end up with 9/16. And then to subtract these, we need a common denominator. So we'll make them both over 16. And remember this is 2 over 1, so to get from 1 to 16, we multiply by 16, so 2 times 16 is 32. And then 32 over 16 minus 9 over 16 is 23 over 16. Or if you want, you can change that to a mixed number. That is 1 and 7/16. Okay. So there's three try it yourself problems at the bottom of the page there. So pause the video and work through those 3 problems. When you're ready to check your answers, press play. Okay, for A, you should have gotten 0. For B, negative 81. And for C, 900. Okay. Let's move on to section 9.2, prime factorization. A prime number is a whole number that has exactly 2 unique factors, 1 and itself. A composite number is a whole number that has more than 2 factors. 0 and 1 are neither prime nor composite. So we first want to determine whether each number is prime or composite. So the number 37, factors of 37 include 1 and 37. There are no other numbers that evenly divide into 37. So this number would be prime. 22 has factors of 1 and 22, but also 2 and 11. So this is not prime, it is composite. 31 has factors of 1 and 31, and nothing else. There are no other numbers that divide evenly into 31, so this is prime. And 36 has a lot of factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So definitely not prime. This is composite. Okay. So there's some for you to try yourself. So you're determining whether each number is prime or composite. If you are not sure if something has other factors, you can always check some that, that could possibly be factors. There are some tricks to tell if numbers are divisible by 3 or divisible by 9, and a few other things. So, you can use some of those tricks if you know those to help you determine if something is prime or composite. If nothing else, you can always use your calculator to divide each of the numbers by numbers that you think could possibly divide evenly into those numbers. So press pause on the video, go ahead and figure out for each of those whether the number is prime or composite, and when you're ready to check your answers, press play. Okay, the first one is prime. The second one is composite. That has 3 and 13 as factors as well. C is composite. It has factors of 3 and 9 in addition to 1 and 27. And D is also composite. It has factors of 7 and 11. Okay, any composite number can be written as the product of prime numbers. A factor tree can be used to find the prime factorization. So we're going to refresh your memory on how to create factor trees. So if I want to write the prime factorization of each number, use exponents for repeated factors, I'm going to use a factor tree to find the prime factorization. So you start with your number that you're factoring, and then we make 2 branches on our tree. There are 2 numbers other than 1 in that number, but 2 numbers other than 1 that multiply to give us this number. So in this case, first thing that came to my mind was 6 and 4. And it doesn't matter which numbers you start with, as long as they multiply to give you this number. So 6 and 4. Well, 6 can still be factored further into 2 and 3. But now 2 is prime and 3 is prime, so neither of these can be factored any further. 4 can still be broken down into 2 times 2. And again, both of those 2's, 2 is prime, so those are finished. So here I see it says use exponents for repeated factors. I see 1, 2, 3 factors of 2, so that's 2 to the third, and then a 3. And the nice thing about these is that you can very easily check these. If this is the correct prime factorization, it should be unique, meaning that if I multiply 2 to the third times 3, it should give me 24. So 2 to the third is 2 times 2 times 2, which is 8. 8 times 3 is 24. So that does come out correctly. Alright, let's do the same thing with 56. Two numbers that multiply to give us 56 are 7 and 8. 7 is prime, so we'll leave this alone. There's nothing else that can be factored with this. 8 factors into 2 times 4, and 4 is 2 times 2. And now we have all prime numbers, 7, 2, 2, and 2. We have 3 factors of 2, so that's 2 to the third, and then a single factor of 7. Okay, last one. 45. Two numbers that multiply to give 45 are 9 and 5. 9 can be factored down still into 3 and 3. 3 times 3 is 9. But both of these are prime, so we're done here. For the 5 is also prime, so we're done over here. So all we have left are prime factors. So this is 3 squared times 5. Okay, so there's 3 for you to try on your own. You're going to use a factor tree to write the prime factorization of each number. So pause the video, create your factor trees, and when you're ready to check your answers, press play. Okay, 16 factors down to 2 to the 4th. 78 is 2 times 3 times 13. And 50 is 2 times 5 squared. Okay. On the last page, at the top it says, a monomial is a number, a variable, or a product of numbers and or variables. And you see examples here of things that are monomials and things that are not monomials. And exactly what makes these not monomials are these other operations: addition, subtraction, subtraction. Monomials are numbers, variables, or a product. This is just multiplication of numbers and or variables. If there's any addition, subtraction, or division involved, it is not a monomial. In algebra, monomials can be factored as a product of prime numbers and variables with no exponent greater than 1. For example, 8x squared factors as 2 times 2 times 2 times x times x. This 2 times 2 times 2 is just 8 factored down. And then x times x, because this is x squared. Negative coefficients can be factored using -1 as a factor. So we still want to factor these, but they're going to look a little bit different because there are some variables involved. So factor each monomial. For the first one, we have 10xy. And before we can do anything, we need to factor the number 10 so that we have that down to prime factors. And 10, two numbers that multiply to give us 10, are 2 and 5. Okay, and both of those are prime, so we can't factor any further. So I could factor this monomial by saying that this is 2 times 5, just like we did on the previous page. But then we have xy, so times x times y. Alright, for b, we'll first factor the 12. 12 is 2 times 6, 2 is prime, 6 is 2 times 3, and 2 and 3 are both prime. So this is 2 times 2 times 3 times the q squared, so that's q times q, and r to the third, r times r times r. Okay. And one more. Here we see the negative there, which means I have a factor of -1 to deal with. So this just means there's a -1. We'll factor 18. 18 is 2 times 9. The 2 is prime, so we'll factor the 9 further as 3 times 3. So as far as numbers go, we have these factors, but then we also have this factor of -1 to make sure we remember. So -1 times 2 times 3 times 3. And then for the variables, there's a single m and n to the 4th. So 1, 2, 3, 4. Okay. And those are the factorizations of each of those monomials. Right, there's some for you to try on your own, so pause the video, work through those 3 problems, and when you're ready to check your answers, press play. For A, you should have 3 times G times G times G times H times H. For B, this is 2 times 2 times 2 times 2 times P times Q times Q times Q times Q. And C is -1 times 3 times 7 times X times X times Y. Okay, and that is it for section 9.1 and 9.2.